Welcome to the Mirteq video instruction series. In this video we'll be looking at our electronically controlled MIR-1000 gear pump. We have a second model on the drawing board which will be a little bit less sophisticated and will operate with a single motor and a manual gearbox. It will also be priced accordingly. Both pump models will be able to inject our MIR-1000 resin and also our microfiber material. We developed these pumps because of the need to carefully regulate the catalyzation of our MIR-1000 material and ensure that we achieve a good material mix, which we were not able to achieve with a simple piston pump. So let's have a closer look at this electronically controlled gear pump. It has two motors, one for the resin and the other for the catalyst. It has two independent speed controllers. You dial in the flow using these up and down arrows, and if you need any help, the various settings are available on the chart on the inside of the control box. The independent drives give us the flexibility to adjust the pump and catalyst flow, which is ideal for larger parts where you might need more than 1 pound per minute in order to beat the gel time, or where you have thicker components and need to reduce the catalyzation. While the pump is operating, the catalyst flow rate is regulated by this electronic flow meter. This manages any slippage in the catalyst pump due to flow rates or pressure on the head due to the material's viscosity or size of the part being injected. And this electronic readout here reports your precise catalyzation while the pump is operating. The readout fluctuates within a narrow band. These two pressure gauges measure the pressure right out of each pump. The two gauges near the mix head measure the resin and catalyst pressure at the mix head. We also have next to each pump outlet independent pressure valves to guarantee the pump's safe operation. Down here on the base of the pump we have a pressurized acetone tank, catalyst container and resin overflow container that only ever fills if we overpressurize the system. So to operate the pump, you fill the resin, catalyst and acetone containers, you bleed the catalyst line, switch it on and wait for the catalyst to flow out of the injection head. You then switch on the resin pump and wait for the resin to flow out of the mixing wand and injection line. You let it run into the waste bucket for 10 to 15 seconds in order to flush out any air that might be in the system. The wand holds 1/4 pound of material, plus whatever material you have in your delivery hose. Once you have filled the wand with catalyzed resin, you are ready to inject. As I said earlier, you should only fill the wand and bleed the system immediately prior to use. To clean the pump, it's quite a simple process. When you have finished your injection, you switch on the catalyst pump, you then flush compressed air through the mix head. You then flush the system with acetone and you repeat the process 3 times. The last thing you need to do is run the catalyst for a further 10 seconds to ensure no resin is left on the tip of the plastic line in the mix head. If you ever do have resin set up in the catalyst line, all you need to do is replace the 2-inch tube in the injection head. When doing so, you should ensure that the catalyst tube protrudes about 1/4 inch so that the catalyst is injected directly into the resin flow. So moving on from the pump mechanics, let me explain why we developed this sophisticated and precise injection unit. MIR-1000 is a high viscosity material. At 60 degrees Fahrenheit, its viscosity is 8,000 centipoise, which is equivalent to a thick syrup. When heated to 85 F, its viscosity decreases to 4,000 centipoise, which is similar to a light honey. So we recommend mixing the catalyst and MIR-1000 between 85 and 90 degrees Fahrenheit. This pump has been designed to mix the material in that temperature range. With the wand we get a really good outcome and the material performs as intended. A few words of caution here, and as everyone with a resin background knows, you should not heat any resin above 100 degrees Fahrenheit because the styrene can evaporate. You'll also have another issue when you heat the resin, and that your gel time will decrease, which is certainly not a good idea if you're trying to mold big parts. If you need to adjust your gel time for any reason, do not hesitate to contact us directly. And one last thing while I'm talking about mixing, and if you have any doubts about why we use the big mixing wand, have a look at the accompanying YouTube link to the University of New Mexico's laminar flow test. It's a very graphic illustration and shows why we need to reduce the resin's viscosity and why we use the big static mixer. I hope you have enjoyed looking at the self-maintenance Mirteq pump. It is simple to use, really easy to maintain, and does not cost an arm and a leg. It is practical, precise, reliable, and it works really well. I'm sure we'll continue to develop it and make it even more user-friendly in time to come. So there you have it. We've covered a considerable amount of ground with this video. If you still have any questions and cannot find the answers in this video series, call us directly or send us an email.